What's going on, electricians? I want to talk about a question out of my book, A Comprehensive Guide, that one of my viewers DM'd me, and it's kind of challenging the conclusion I got from this book. It is a question regarding motors. Before I get into it, I did want to give this picture, just kind of describing what it is that we're going on here. So we have a switchboard and a motor control center. This switchboard is usually the bigger of the two, and it has multiple overcurrent protective devices. There is a particular overcurrent protective device that passes power to the motor control center. Here, I'm going to call that the feeder overcurrent protective device. Okay, this is the feeder OCPD powering this motor control center, and from here we have smaller overcurrent protective devices that pass on power to motor 1, motor 2, motor 3, and motor 4. So those are my branch circuit overcurrent protective device, and here is my feeder overcurrent protective device. So the question in question is talking about how do we size the feeder overcurrent protective device. So this is the protective device that we are trying to size. Now that we have a picture, kind of have a little bit more understanding what's going on here, let's get to the question. All right, so the question we're reading is Quiz 4, Question 3. It says a feeder supplies 3 460-volt, 3-phase, 1740 RPM, Design B, alternating current motors. The motors have the following nameplate ratings: 25 horsepower, 28.4 amps, 15 horsepower, 18.2, and 7.5 horsepower, 11.3 amps. What is the minimum size feeder inverse time circuit breaker required to protect this motor? Okay, first off, I'm just going to say I'm not actually going to answer this question, but I am going to address the DM that I received. So I got a final answer, and this gentleman said, hold on, your answer is incorrect because you didn't round up. Okay, so for certain motor applications, whether it's it could be sizing the branch circuit overcurrent protective device, you will often see if the calculated ampacity does not correspond to a standard ampere rating for an overcurrent protective device, you can go to the next size up in accordance with table 240.6. If you are a journeyman electrician or a master, this is going to ring some bells. You're going to know, oh yeah, that's the next size up rule. We use that all the time. And this guy challenged me. He said, hey, you didn't round up, therefore your answer is wrong. Well, I am going to challenge that line of thinking and say, hold on, for certain cases you're correct. But remember, we are sizing the feeder overcurrent protective device, and that particular code article doesn't say that we can round up. So let's open up our code books and I'll show you where. Okay, so we're in Article 430. We're specifically in Part 5 where it talks about motor, feeder, short circuit, and ground fault protection, so we know we're in the right area. The code article that we're going to be reading is Article 430.62, rating or setting for motor loads. And now A says specific load. Now, this code article is very hard to read, so try to follow along. So it says, a feeder supplying a specific fixed motor load or loads and consisting of conductor sizes in accordance with 430.24 shall be provided with a protective device having a rating or setting not greater than. Okay, I'm just going to pause there. Not greater than. So whatever this code article tells me to do, the way I'm calculating, the ampacity that I conclude, my protective device shall not be greater than this number. Okay, so that's why immediately I'm like, okay, I'm not rounding up. But let's continue. Rating or setting not greater than the largest rating or setting of the branch circuit, short circuit, ground fault protective device for any motor supplied by the feeder based on the device for any motor supplied by the feeder. Sorry, based on the maximum permitted value for the specific type of protective device in accordance with 430.52 or 440.22a for hermetic refrigerant and motor compressor, plus the sum of the full load currents of the other motors of the group. Okay, I know that was kind of all over the place, but again, nowhere in this code article, if you continue reading the exceptions, nowhere in this code article does this say, hey, we can go to the next size up. If it did, I would have done it. But this is specifically saying it shall be provided with a protective device not greater than whatever we're calculating. Okay, so I have other videos where I describe this code article in detail, explaining how to get the answer to the question in question and to what I wrote on the board. Comment down below if you want me to do a video explaining that, but in this video I just wanted to describe this, okay? Whatever it's telling us to calculate, the ampacity that you conclude, we have to select an overcurrent protective device that does not exceed that number, okay? If you do, it's too big, it's a code violation, we cannot exceed that number. Hopefully that makes sense. Again, comment down below if that made sense to you, if you have any other questions, if you want me to elaborate a little bit more, I have no problem doing that, but I just wanted to address that DM. Again, just having a conversation. No hate. I totally get the question. Totally understandable. Let's all agree that the code is difficult to read. It's not straightforward. If it was, everybody would be an electrician, but it's just not straightforward. Hopefully that makes sense. Comment down below if you understand or if you need some clarity. Thanks.